Hello everyone, in this video we're going to talk about how to factor polynomials through a method called grouping. Now, there are a ton of different types of polynomials and a ton of different types of methods to solve them. Just like for quadratics, there was a lot of different methods and approaches that we did. But we're only, for time purposes, going to focus on two methods, this being one of them, factoring by grouping. So these polynomials we're going to be focused on are going to be looking like this. ax to the third plus bx squared plus cx plus d. We could look at polynomials with a higher degree, right? Like to the fourth, to the fifth, or other exponents. But since this unit is primarily focusing on cubic functions, we're going to focus on how do you find the factors of this using grouping. So as I said earlier, we've done a ton of factoring already. We've done Lopez approach. We've done difference between two squares. We've even done quadratic formula to look at some stuff, and even the graphing method as well to solve for the x-intercepts and things like that. So when you're factoring, you're looking for the two things that are going to multiply to give you this original function, right? We did a method which I call Lopez approach, where you looked at the factors where you can cross multiply and see if it added up to b. And when it did work out, we said we have two factors here, x plus 4 and x plus 1. And those two factors are the equivalent representation of this. It's just written in a different notation, and factored notation, where two things multiplied to give you that. And we even checked our work by doing box method and to see if it actually matched what we said it was going to be. We're going to do something very similar when we're looking for the factors, but of a higher degree polynomial. So let's do a few examples. Let's look into the methods and let's talk about it into more detail. So here we have a cubic function, 5x to the third power minus 10x squared plus 6x minus 12. I cannot do the column method here and cross multiply because we have more than 3 columns. We have 4. That's not going to work. We're going to use a method called grouping, in which we group them into two parts. The first group, I'm going to label it as the blue group, and the red one as a red group. Or group 1, group 2, however you want to label this. I'm just going to do it by color so you can sort of distinguish the difference. The first thing that I want to look at is, do these have something in common? 5, 10, 6, and 12. Do they all share a factor in common, a greatest common factor? And the answer is no. 5 and 10 have something in common, but 6 is not divisible by 5. 10, 6, and 12 are all divisible by 2, but then we're leaving out the 5. Notice how the first 3 terms have an x, but the last one doesn't. So they all 4 terms don't have one thing in common that works for everything. This is why we're forced to solve it by grouping. We're going to separate into 2 groups, solve them separately, and then bring the problem back together to solve it in the end. So let's focus on the blue group. I want to find the factors or the things that I can pull out from this blue section. This group number 1. I notice that these first 2 terms are divisible by 5. I also know that they both have x's. And the largest x value that I can fit into both of them is going to be an x squared. So 5x squared fits into here and into here. So we call this the greatest common factor. This is one factor. Well, we need to multiply this times something to get what we came from. And this something is really what we do is like reverse distributive property. 5x squared times x gives me 5x cubed. 5x squared times something is going to give me negative 10x squared. And that something is negative 2. These are the 2 factors of the first group of the equation, or of the expression. A way to check your work or to see if you're following through is to distributive property. Does it give you 5x cubed? Does that give you negative 10x squared? If it does, you find yourself 2 factors. I'm going to do something very similar with the red group. Okay? So in the red group, I notice that the 6 and the 12 are both divisible by 6. So I'm going to factor out a positive 6. 6 times x gives me 6x, and 6 times negative 2 gives me negative 12. See how I also found the factors of the red group? So here I split the problem into two parts, the blue group and the red group. I found the factors separately. Now I take a step back and I look at the two groups. Is there something that the blue group and the red group share or have in common? And you're right, this part, the x minus 2, they both share that in common. So in the very beginning, they shared nothing in common. Nothing up here was that they had in common. And now, by factoring them separately, I found that they both have an x minus 2 in common. And that's going to be the factor, the first factor that I'm going to pull from the entire equation. So from the entire equation, I can factor out an x minus 2. I need to multiply it by something to get the previous step, right? Multiplying these together should give me this. So since I'm factoring it out, what I can say is I'm going to pull it out of the first term. When I pull it out here, I'm left with 5x squared in the beginning. When I pull it out of the second group, I'm left with positive 6. And I have my two factors. I have x minus 2 times 5x squared plus 6 will then give me our original problem. Those are the two factors. When you're dealing with cubic functions, you're going to have a linear factor and a quadratic factor because 5x squared times x will eventually give you 5x cubed. And if we wanted, we could do box method and try this out. Multiply everything to see how this comes back to the original problem. Okay, there's another video on multiplying polynomials if you want to know how do you multiply these two to check your work. Okay, let's try another example. Okay, as I said in the previous example, all of those four terms share nothing in common. These two have something in common. All these three have an x, but notice how this term, this term, this term, and this term all don't have one thing in common. So I'm forced to do this by grouping. Group number 1, I have x cubed plus 7x. What do they share in common? Actually, that 7x should actually be a 7x squared. My bad. What do these two terms have in common? They have an x in common. What is the highest x that I can pull out of both terms? That's going to be an x squared. So that's my first factor. X squared times what is going to give me x cubed? It's an x. And x squared times what is going to give me a 7x squared? That's a positive 7. I then look at my second set of factors. We're going to call this the red group. And I look at what do they have in common. I notice that they're both divisible by a negative 2. So I'm going to pull out a negative 2. And I was supposed to be doing this in two different colors. I'll just do this in red so we can see the difference. When I factor out a negative 2, I can say negative 2 times x is negative 2x. And negative 2 times positive 7 is negative 14. This one in black in the front should have been in blue. But now do we notice how the blue or the black group number 1 and group number 2 actually now share something in common? If you do this correctly, it'll always be what's in parentheses that they both share in common. So I'm going to extract that first as my first factor. X plus 7 becomes my first factor. The second factor is what's left over. So if I pull it out of the first group, I'm left over with an x squared. If I pull it out of the second group, I'm left over with a minus 2. And these are the factors of my cubic function. So, factor them separately, then realize what do they have in common, and that's the first factor you're going to find out from both of them. When you multiply them, if you want to do box method, you can multiply things and check your work again and get back to the original problem. So, these are the general steps that you can expect for a general function. Okay? any general function for factoring, you're going to break it into two groups. Group 1 and Group 2. Group 1, you're going to want to pull out the greatest common factor. Okay, so usually going to be some sort of x squared. Maybe there's a number in front of it. In the back, you're going to have your x minus your number. Right? And you can check your work by doing distributive property to see if it gives you the blue group. Then you do something similar with the red group. What do they both have in common? Pull out that number, and that leaves you with x minus your number. Check your work. Notice how these two groups now actually share the parentheses in common, and that's what I'm going to pull out in the end. That's my first factor. When I pull it out, I'm left with an x squared, and on the back, I'm left with an x, or a number of some sort. Now, this is all going to vary, right? Because it can have an x, it can have a 2x squared, it could have numbers, it could be anything. I'm just telling you the general form is you start by factoring the first group, pull out the two terms, factor the second group, pull out the two terms, take a big picture out, take a step back, and realize that the parentheses should be identical. You then pull the parentheses out, and whatever you're left with is going to be your second factor. And that, my friends, is how you factor by grouping. Please let me know if you have any questions below. I hope this helps. If you have not subscribed yet, go ahead and hit the subscribe button. And as always, we will calculate later.